This video will describe how to complete Jamovi Project 4, which covers ANOVA. Remember, ANOVA is trying to detect differences in population means for more than two populations. If you just have two populations, you can use a t-test. So in the actual project, you're going to use the House K3 data file there, and you're going to generate descriptive statistics and fill in your mean, standard deviation, sample size in this table. And you're going to do that by doing ANOVA, one-way ANOVA under the analyses. So let's take a look at an example here. So here we've got region of the country, Northeast, Midwest, South, and West, and then this is utility usage. And we want to see if there's a difference in mean utility usage. So we will go to ANOVA, and then one-way ANOVA. Region is our grouping variable. For you, it's going to be city, and then usage is going to be our dependent variable. For you, it's going to be cost. So we're seeing a p-value here of 0.021. That's assuming equal variances, Welch's. The directions in the project say, not assuming equal variances. Directions in the project say assume equal variances. You want to make sure Fisher's is clicked. So there we see a 0.005. Significant. So there is a significant difference between the regions in utility usage. Also click on descriptives, and that will give your sample size, mean, and standard deviation, so you can fill in this table. And then we also want to generate the ANOVA table and fill that in. In order to do that, you're going to go up to the Analysis tab again, ANOVA, and then click on ANOVA. So you'll get this dialog window. Region is going to be your fixed factor. Again, for you guys, it's going to be city. Usages are dependent. And we can see down here that it has generated the ANOVA table. Notice it didn't total things up, but that's easy. You can just total these columns here. Notice we got that same p-value of 0.005 that we saw up here. So ANOVA will generate the actual ANOVA table. One-way ANOVA just gives our summary. Now we also want to see which differences are significant here. So we're going to go down to post hoc tests. We're going to take region and pull it over as our grouping variable. For you, again, it'll be city. And then we are not going to do Tukey. We are going to do Bonferroni in this project. So remember, Tukey and Bonferroni, two different types of post hoc tests. So what we see here is that we have a significant difference, and then down here we want to look at the last column, p-values here. That's p Bonferroni is what that is, the p-value for the difference. And we see that only two of these are less than 0.05, which is here and here. So that's going to be Midwest minus South with a mean difference of 4.5, and Midwest minus West with a mean difference of 5.3. Those are the significant differences. So this said significant differences, and here we actually found significant differences. So after you've got your table filled in here, you're going to state your null and alternative. All means equal, at least two means differ. Based on the ANOVA table, in other words, looking at the p-value, what's the outcome? So p less than 0.05, there is a significant difference. You will reject H0. P greater than 0.05, you will not reject. And that's this p-value here. And then look at p Bonferroni, and it's asking you which differences are significant. So in our example, we saw that these two differences were significant. So you'll look and see if cost is different between any pair of cities. And then, are the results with the ANOVA consistent with the Bonferroni comparisons? So here, this is saying there is a significant difference. We did find differences down here. If this was significant difference here, but no difference was significant down here, that would be inconsistent. Okay, but this data is consistent. And then that pretty much wraps up ANOVA tests here. In the last part of the project, you're going to do the same thing, except you're going to use number of bedrooms here as your grouping variable instead of city. So you're going to see if the average price varies based on the number of bedrooms. So you go through all the same steps again, different grouping variable.